Hello students, welcome to class 11 physics. In this video we are going to discuss about the conservation of linear momentum of chapter 5 laws of motion. Explain conservation of linear momentum by suitable example. Law of conservation of linear momentum can be obtained by using Newton's second law and third law of motion. We know that for the isolated system, total linear momentum of system remains constant. This is the statement for the conservation of momentum. Let us see one example. When bullet is fired from gun, bullet moves in forward direction and gun moves in backward direction, that is recoil. Force applied by gun on bullet be vector F. Then force applied bullet on the gun be minus F. These two forces act for equal time interval delta t. So here when the bullet is fired from the gun, there are two forces that will be acting. That is the force F on the bullet, which will be in the forward direction, and the force that is applied on the gun, that will be in the backward direction, that is opposite to that of the force applied on the bullet. And these two forces will be acting in equal interval of time, that is delta t. Therefore, by second law of motion, we can say that change in momentum of bullet is equals to F delta t. We have already studied the second law of motion, that time rate of change of the momentum is proportional to the force applied to the object. That is vector F is equals to delta P vector upon delta T. From these equation, taking delta T on the other side, we can write F delta T equals to delta P, where delta P is the change in the momentum. So here in terms of that, we can write the change in the momentum, that is delta P is equals to F delta T. So the change in the momentum of bullet is F delta T, and change in the momentum of the rifle or the gun is minus F delta T, because over here for the gun force is minus F. So change in momentum delta P for that is equals to minus F delta T. So initially both are at rest, hence the change in momentum of both is equal to the final momentum. Here first let us consider the case of the bullet. Then for that, change in momentum, that is equals to final momentum minus the initial momentum. Final momentum is equals to Pf minus initial momentum, that is 0, because here we know that momentum is product of mass into velocity, and initially the bullet is at rest. So velocity will be 0 and thus the initial momentum will be 0. So for bullet, change in momentum is equals to the final momentum for bullet. And in the same way, change in momentum for the gun, that will also be equal to the final momentum, because initially the gun is at rest, so its velocity will be 0, so the initial momentum will also be 0. Here we can write that in terms of F delta t, because we know that delta P is equals to F delta t. So change in momentum is equals to the final momentum that we have already seen. So the final momentum of the gun, let us denote it by Pg, and the momentum of the bullet, that is denoted by Pb. Thus we can write over here that F delta T for bullet equals to Pb, and for gun it will be minus F delta T equals to P G. So taking this minus sign over here, this side becomes plus. So F delta T is equals to PB and F delta T equals to minus PG. So we can compare these two and write PB equals to minus PG. So PB equals to minus PG, taking minus PB on the left hand side, it is PG plus PB equals to 0. So we can say that the total linear momentum of the system, a system consisting of the gun and the bullet, the total linear momentum of the system is conserved. So we can write this statement: conservation of momentum. For isolated system, total linear momentum of system remains constant. Now example, consider two objects A and B. Let their initial momentum be PA and PB. Let after the collision their momentum be PA dash and PB dash. So by second law of motion, as we know that the change in the momentum delta P is equals to F delta T, and change in momentum is nothing but final momentum minus the initial momentum. So we can write for object A as FAB delta T equals to final momentum on object A and final momentum of object A. Initial momentum of object A, that is PA dash minus PA, that is the final momentum of object A and initial momentum of object A. So for object A, FAB delta T is equals to PA dash minus PA, and for object B it is FBA delta T equals to PB dash minus PB. Here it is just PB, that is the initial momentum of object B. So from the Newton's third law of motion, we can say that FAB equals to minus FBA. So using this equation, taking delta T on both the sides, multiplying both the sides by delta T. So we get FAB delta T equals to minus FBA delta T. And using this equation FAB delta T and FBA delta T in this equation, we get as P dash A minus PA equals to minus P dash B minus PP. So rearranging this, we get PA dash plus PB dash equals to PA plus PB. So here we are taking the objects A and B as a system whole. So we can say the final momentum of the system having objects A and B is equal to the initial momentum of the system having objects A and B. Thus for isolated system, total final momentum is equal to total initial momentum. In both elastic and non-elastic collision, momentum is conserved. But in elastic collision, both momentum and kinetic energy is conserved. Law of conservation of linear momentum is universal and fundamental. It equally holds true of system of smaller particles like electron, proton and neutron, as well as the larger system that is considered as the macroscopic level particles. So students, you may note down this theory.